Yeah. So hello guys, myself Rahul Jaswal. I am passed out from NIT Tiruchirappalli in thermal engineering. So I'm going to take the engineering mechanics for you for upcoming HL examination. So just I want to confirm that whether I'm audible or not properly. If you can check it out.
Audible, sir.
Okay. You can write in the chat section instead of saying. Okay. So first of all, in the engineering mechanics, we are going to see the syllabus that we need to cover, right? Engineering mechanics syllabus that we need to see. And of course, the syllabus will be same as the GATE syllabus, but some of the parts that is there in the GATE syllabus, I'm not going to cover because that is not going to come in the HL examination, right? In fact, the questions which are there in the GATE examination, that is not going to come in the remaining PSU examination also, right? So first of all, the syllabus part we are going to cover in the first chapter, the free body diagram and the equilibrium system, right? Then we are going to cover the friction and its application, then trusses and the frames, then kinematics and dynamics analysis of the body in a plane motion, right? We have the motion like translation, rotation, and the plane motion, right? When I talk about the plane motion, so in the plane motion we have the rotation as well as translation also, and then we have the impulse momentum, right? Impulse momentum theorem, and then we have the work done energy theorem, right? The total work done will be what? Change in the kinetic energy. And of course, do not worry, each and everything will be covered beautifully so that at the end of the session, at the end of the session, you will not be having any doubts. Now, coming to the reference book, these are the syllabus that is there. And of course, this syllabus will be in line with the GATE syllabus. Whatever the syllabus, these are there, that is already mentioned in the GATE 2022 syllabus, right? So I'm going to cover this particular subject in such a way that suppose those who want to write GATE examination, right, 2023 next year, you will be getting some idea, and of course some questions I'm going to discuss so that at least those who are not having basics, right, they will get some basic idea about the subject as well as many concepts, so that in fact you can appear in the GATE examination also, and in fact you can just solve all the previous year that has been asked in the GATE examination, right? Now, coming to the reference books that I will suggest that the first reference book will be, the Merriam and the Craig. That is a very beautiful book we have, right? In fact, in this book, all the things are covered, statics as well as dynamics. And of course, we have the two books, statics as well as dynamics book. Two parties there for this particular Merriam as well as Craig, right? But for the initial classes, right? Suppose that for initial, suppose you want to get some idea about the engineering mechanics subject, I will not suggest this particular book, right? Because this is very, very high level book. Once you have the concept understanding and clarity about the subject, then you can follow this particular book, right? And after that, what we can have, the second book is nothing but, suppose when you are initial learner for this particular engineering mechanics subject, then you can have the ISS Bhavi Katti book, right? This is also one of the good book, but still we have some mistake in the SS Bhavi Katti in the rotational dynamics. When we are going to discuss rotational dynamics and when we are going to solve the numerical, in that you will find some of the mistake actually, right? So of course, before that part you can easily cover with the book called SS Bhavi Katti, right? But apart from that, the cream book is what? Sorry. Apart from that, I would recommend that you just follow TL Kumar. It will be more than sufficient for at least for GATE examination, right? Because we have seen in the past year, for the past GATE previous year question, when I just talk about the previous year question of the GATE, right, that has been said by what? IIT professors, right? And the KL Kumar is nothing but what? Former IIT Delhi professor. So directly some of the good questions, in fact many questions are there when you just follow the previous year question, around we have 100 questions, suppose that, but out of that 100 questions, suppose 5 to 6 or maybe 10 questions are of the very, very good level, that has been taken directly from what? KL Kumar, right? So these are the 3 references book. Suppose you are at the initial stage, just follow Bhavikatti, right? Or maybe you can follow, A.K. Tayal. And after that, you can follow K.L. Kumar. Once you have the basic understanding and the basic idea about the subject, then you can just play with the topic called Engineering Mechanics with the book called Merriam and Craig, right? So all of you are getting my point, what I'm talking about? Tell me, guys. All of you. All of you are understanding? Yes? Okay. So these are the basically that the syllabus part as well as references book that will be important for you to basically crack these particular examination. Now regarding the preparation strategy, because first 10 minutes I'm going to discuss about this thing only, so that you'll be having some basic understanding like how to prepare for this examination, right? PSU examination. So here I'm going to just cover small basic idea about this. Now, the preparation strategy will be going something like this. Suppose in HL examination, if I just talk about, you will be having around 160 question. 160 question you are going to have it, right? And what will be the time duration? 150 minutes, right? So hardly you are going to have less than 1 minute for any question, right? So you are not going to have a lot of amount of time for basically for each and every question. So definitely one idea you are getting from this is, what is the idea you are getting? At least you are getting some idea that the question will be not the lengthy one, not lengthy or calculation wise. It will not be so calculative, right? That is the first thing that we are getting idea out of this particular time duration as well as number of the questions. The second thing is that we have to cover GATE previous year question, all 1 marks for technical subjects. Whatever the technical subjects are there, section 2, section 3, section 4. Out of that, if you just cover 1 mark question, all the theoretical question as well as numerical question, not 2 mark question. Some theoretical question you can take it from the 2 marks, but 1 marks you can directly take, whatever the GATE previous year question papers are there, right? You have the question paper of the GATE from 1990, right? Till date. So you can cover that. That will be one kind of basically source for the material. And the third thing will be ESC previous year objective. That is a mandatory kind of thing. Because many times, if you just follow RS Khurmi, right? In fact, I will mention the 4th option also, RS Khurmi. But the problem with the RS Khurmi is that there are a lot of blunders are there, a lot of mistakes are there. Suppose in the answer also, a lot of things. In fact, if you just follow 150 questions, suppose that. So 150 question, maybe it may be possible that 10 to 11 questions may be wrong in that book. But still you need to follow that RS Khurmi because the questions are directly coming in the PSU examination. But do not worry, once you follow the ESC previous year question paper, directly the RS Khurmi has taken some of the questions from ESC only, right? So both are interlinked, right? So all the objective questions of the ESC, numerical as well as theoretical question, both you need to cover from the ESC previous year question paper. The GATE paper, all the 1 mark question that you need to cover, RS Khurmi that you need to cover. Along with that, you need to make the short notes. Short notes are very, very important, believe me, right? Because you have hardly 30 days for examination, suppose that, right? So you don't have that much of time. So what you do, once the subject has been finished, suppose that casting is going to be finished, you just try to finish on the same day itself. Try to make the basically short notes from the class notes itself, and after that try to prepare on the same day, and try to follow the ESC previous year question, past previous year question, past previous question on the what? All the questions on the casting. You try to just apply those things. GATE question also on the casting. Not very calculative numerical, just I'm saying that theoretical questions, and try to make the short notes of that, right? These are the strategy if you just follow and try to practice, and you try to memorize it like anything, at least 5 times, before going to examination. After that, what will happen? Whatever the easy questions are there, directly you can take it out, and remaining time you can just allot to what? Reasoning and English questions. Whatever the comprehensive question will be there, that there you can allot the time. Are you getting my point, all of you? Right? Okay. So these are the preparation strategy that you must follow. And of course, in this class, I'm going to cover all the previous PSU papers, right? Those has been asked in the, basically Telangana Public Service Commission, Andhra Pradesh Public Service Commission. In fact, many PSU examination like HPCL, right? CGPSC, HPSC, right? UPPSC, all the examination that already been asked questions. Those are repetitive. They are not framing the new question. Remember that, right? And remember, this examination will be different than other PSU examination because here you will be having some mathematics question also, right? So apart from this, add mathematics. Just follow the gate previous year paper. Just follow gate previous year question. That's it. Right? Try to follow the concept of the mathematics and try to stick with the previous year question. You will be getting the question from the complex, function, complex variable, and some of the differential equation, and Laplace transformation. These are the questions will be there, right? Because in the last year memory based question that those has been shared by the student, in that we have seen that some of the questions from these particular topics of the mathematics. Yes or no, guys? So is that clear? I just want to say that about the syllabus, books, and then the preparation strategy, whether these things are clear or not. Do not worry about the subject. After the completing this particular today's session, you will feel that you are getting something about this, right? So absolutely do not worry about the course. Now, so first thing we are going to cover is that, mathematics, you can just follow gate previous year question, right? Whatever the topic I'm saying, that the topics are complex variable, right? Matrix, differential equation, Laplace. They have mentioned the gate syllabus, so I don't know this year what they can ask, but at least this 4 topic you can prepare thoroughly. This 4 mathematics topic, right? Remember, your priority must be this one, after this one, and then you can go for this particular book, right? Merriam and Craig. In fact, you can follow, suppose that those who are not able to find Merriam and Craig book, in fact, I have all the book PDF, but suppose that you just want to learn some more thing about this, then you can follow Hibbeler. But those are the very, very standard. Do not go for HL examination. Just stick with the SS Bhavikatti or KL Kumar. That's it. In fact, you do not worry about the HL. Just follow my notes. That will be more than sufficient, right? Now, so all of you have noted down. Right? Now, just note on the first topic that we are going to cover. See, fundamentally, you should be strong for cracking any examination, right? Just memorizing the things, keep on memorizing, that will not help you, believe me. Just you need to be fundamentally strong. Once you're strong in the engineering mechanics, then you can have the you can develop the understanding for strength of material. Then you can just study machine design. Then you can follow theory of machine. All the design subjects are interrelated actually, right? How? I will show you. Suppose that you are studying engineering mechanics. Right? And if I just ask you the difference between, suppose that many of you are in the final year, so they might have studied in the second year, that is first year in the engineering mechanics, and in the second year they might have studied strength of material. As of now, if I'll just ask you the difference, what you will say? Start telling me one by one. Whatever it may be, correct or incorrect, it doesn't matter. Just I want to know some of you, like some of the idea from you guys. What is the difference between engineering mechanics and strength of material? Sometimes both looks very similar, right? But there is a lot of difference. Tell me, guys. Yes. Anyone? Any idea about this? The difference between engineering mechanics. Properties of the elements. Is it so? Suppose that if I just take the example, if I just take the example, still I'm not getting any answer. Please tell me, guys. Answers. Any answers? The difference between engineering mechanics and strength of material. Suppose you are applying the force P, right, in this object. There is a cylindrical bar or maybe anything, any rectangular bar you can take. After application, suppose that length is L. After application of the load P, suppose that this body is what translating to this position, right? After translating also, the length of the body is what same. Initial length and final lengths are same. Suppose that. And you can take the point A here and you can take the point B. After translating, after application of the load, the body has been translated. Suppose that. Now tell me whether length has been changed between point A and B. Tell me, guys. The length has not been changed. When the length has not been changed, then what we can say? The relative position, the relative distance between the 2 points in a body, between the 2 points in a body does not change. When the relative distance are not changing, then we say what? Rigid body. Then we say rigid body, right? But my dear friend, just take the example number 1 and talking about the example number 2 now. But when you just talk about the example number 1, once you apply the load once you apply the load P to this particular body, having the same length, you can take the length to be same. What will happen? This body will deform. Now, let's suppose that A and B are the points. And after the basically application of the load, suppose A dash here and B dash over here. Now tell me what is the length. Initial length is L1. Now what about the final length? Now the final length is what? More than L1. Now the relative distance has been changed. When relative distance has been changed, then what we can say? It's a deformable body. Yes or no, guys? Tell me, guys. When the relative distance between the two particles, when the relative distance between the two particles in a body is changed, then what we can say? It's a deformable body, non-rigid body, right? Strength of material deal with the deformable bodies. Engineering mechanics deal with the rigid bodies. Understanding? All of you are understanding my point? Please note it down. All of you have noted down? All of you have noted down? Whether it's clear the difference between engineering mechanics and strength of material, right? So engineering mechanics deal with the rigid body, and strength of material deal with the deformable bodies, right? Now, the second thing is very, very important is that in the first chapter, we are going to cover the resultant of the forces. Very first topic I'm going to cover is what? The resultant of the forces. Please note on the topic. Resultant of the forces. The first chapter I'm going to cover is resultant of the force system. Note down. Very, very important. Sorry. Just make this diagram. Make this diagram. Both the diagrams. Anybody know about the parallelogram law of forces? Anybody know about the parallelogram law of forces? Tell me, guys. And why we are using it? Suppose that at a particular point, two forces are acting. Suppose that at a particular point, two forces are acting. At the point here, the two forces are acting, F1 and F2. And I just want to find the resultant of these particular two forces. If I just want to find the resultant of these two particular forces, then how we can find this resultant? How we can find the resultant? We can just follow the, we can just find the resultant based on the parallelogram law of forces. What do you do? Suppose that F2 force is acting over here, right? And F1 force is acting over here, right? Then what will happen? The resultant will be somewhere here, suppose that. And the resultant is making angle what? The resultant is making some angle alpha with the what? F1 force. Remember the angle and remember with respect to what force we are taking the angle, right? And theta is nothing but what? The theta is nothing but included angle between what? Two forces. What is the theta? Angle between the two forces. Angle between the two forces, right? Now what you do? I'm just going to make the parallelogram by drawing this one and then this one. What about this? This is F2. If this is F2, what about this one? Can I write F2 cos theta? And can I say this will be F2 sin theta? Check it out. All of you, please check it out. And then by Pythagoras theorem in triangle ACE. In triangle ACE, what we can write? In triangle ACE, what we can write, my dear friends? R square will be equal to what? F1 plus F2 cos theta whole square plus F2 sin theta whole square. Yes or no, guys? Yes or no, guys? Whether it's clear? Parallelogram, basically Pythagoras theorem. Now, how to resolve this one? How to resolve this one? First of all, note down the diagram and note down till this point. Then we can see in the next slide. So whenever the two forces are acting, then you can just follow the parallelogram law of forces, and whatever the formula that we are getting after the derivation, that you can follow for finding the resultant of two particular forces. Right? This is a very famous basically derivation that you just come across when you just talk about the engineering mechanics, right? And for throughout the syllabus, not only in this subject, in theory of machine also, we are going to follow this particular formula. Now, once it is done, let me know. We can move to the next slide. Done? All of you done? Perfect. Now try to follow the concept. So what I mentioned, R square, that is equal to F1 plus F2 cos theta whole square plus F2 sin theta whole square. Because when you see the triangle, this is what the triangle we are making. This one. This will be the right angle triangle, and we can just apply the Pythagoras theorem, right? So here, when you just try to resolve a plus b whole square, what we can get? A square plus b square plus 2 f1 f2 cos theta plus f2 square into sin square theta. What about this term and this term? Cos square theta plus sin square theta will be equal to 1. Then r square we can just write f1 square plus f2 square plus 2 f1 f2 cos theta. And when you just take the resultant, right, squaring on particular this onto the right hand side, then you can get this particular formula. Very, very important. The resultant of two forces will be like this. But you know that resultant is also one type of what? Force. And force is what? Force is a vector quantity. Vector is going to have magnitude as well as what? Direction. In which direction this resultant force is acting? In which direction this particular resultant force is acting, right? Force 1 is acting over here. Force 2 is acting over here. And I'm going to take the resultant force, something like this, by making the parallelogram like this. The total angle is what? Theta. And what about the angle which is made by this particular resultant will be what? Alpha with respect to x-axis, or with respect to what? Force F1. Then what we can find? Tan alpha from this triangle. If I just make the right angle triangle once again, this right angle triangle. Through this right angle triangle, what you can get it out? What about the tan alpha? Tan alpha will be F2 sin theta. And what about this component? This is F2 cos theta. What about total component? F1 plus F2 cos theta. The same formula, I'm going to get it over here also. Tan alpha will be F2 sin theta divided by what? F1 plus F2 cos theta. Now tell me whether these two formulas are clear or not. Sorry. Whether these two formulas are clear or not. Right? Now, let me ask you one question. When these two forces are acting at an angle 90 degrees, suppose that. When these two particular forces are acting at an angle 90 degree, F1 and F2. Suppose theta is now become what? 90 degree. Put into the formula cos 90. What about the cos 90? Cos 90 will be 0. Then what about the resultant? F1 square plus F2 square. Note down, sorry. Note down this thing, this also along with this. Put a note number 1 and note down. When the two forces are acting perpendicular with respect to each other, then what about the resultant? The resultant will be making an angle what? Alpha. And alpha you can just find by using this particular formula, where theta is what? 90 degree, right? Then what about tan alpha? F2 sin what? 90. Sin 90 is what? 1. And what about this F1 plus F2 cos 90? That will be 0. So what you are going to get it? F2 by F1. That will be alpha. From here, what you can find? Alpha will be tan inverse of F2 by F1. All of you are understanding? Tell me, guys. Right now. Right now, I'm saying that the two forces are acting. Suppose that in a particular body, more than two forces are acting. Suppose that in a particular body, more than two forces are acting. Then we say such a type of system, force system. Remember the difference between force and the force system. Force, we are saying we are just applying the one force or two force on a particular body. The moment we are applying more than two force from surrounding all the corners, then we say it's a force system. Right? All of you are understanding my point? Now, all of you have noted down. Shall we solve the numerical? Perfect. So remember the formula. We need to use the formula to basically find the problem, right? Now try to follow this particular question. See, I have taken all the question from all the particular examination, right? So this question, whatever the question, right now I'm going to follow the first question. So first question, if you just take the resultant of two forces which are acting at a 60° is 7 Newton. When they are acting at right angle, that the resultant will be what? Under root of 34 Newton. Then they are asking, these are the conditions are given. When these conditions are given to you, then what will be those two forces, right? So this has been asked in ISRO examination, ISRO 2017. Whatever the topic we are going to discuss, we are going to have each and every numerical based on that particular topic, right? So that you will come to know that the relevancy of this particular topic, right? All of you, please try to answer. You have the formula, right? You have the formula. What is the resultant formula? The resultant of two forces. Let me just take the two forces to be what? Suppose F1 and F2. Suppose that initially they are at a 60°, then resultant will be what? Then the resultant will be something like this. They have mentioned in the question 7 Newton. When this particular, when they are making at the right angle, then the resultant will be what? R1 is what? 7 Newton. So from here, what we can get? F1 square plus F2 square plus 2 F1 F2 cos 60 will be what? 1 by 2, that will be 49, right? Now, so F1 plus F2 square plus F1 F2 will be 49, right? This is the first equation. What about the second equation I'm going to have? The second resultant will be under root of 34 Newton when it is going to make the right angle triangle, when they are making what? Right angles. Something like this, F1 square plus F2 square. So 34 will be what? F1 square plus F2 square. Put this particular value into this equation. So what you will be getting F1 plus F1 into F2? 15. From the option, you just take it out. The product of two forces must be 15. Whether are you getting in the first option? No. In the second option? No. In the fourth option? No. In the third option, what you are getting? The product of, suppose that F1 is what? 3 Newton and F2 is what? 5 Newton. And when you take the product, you are getting what? 15 Newton. So this will be the right answer. All of your understanding? All of you are understanding? Right? Now, so actually we are moving from very slow and very less level of the question to the very, very high level of the question that we have seen in the previous year GATE examination, right? That I'm going to cover, right? So try to stick with the topics and do not underestimate each and every topic. Suppose that we are studying very light topic. Do not think that it's you already know this thing, right? Because many questions will be coming. Upcoming question will be tough, right? So in that case, you require some of the aptitude. Of course, you need to remember the formula, but apart from that, you need to require some of the what? Aptitude also, right? So just try to stick with the formula. Formulas are very, very important. Now, once it is done, let me know. In a particular body, suppose that in a particular body, a lot of forces are acting. Suppose that four forces are acting, right? So I can call this body to be what? Force system body. Now, if all the forces are acting in a particular body, then what will be the resultant? How to find the resultant? How to find the resultant? That is my question. Sir, you have said that for two forces, you have the formula. But sir, how to find the resultant force when we have multiple forces? Or we can say that force system body. Anybody having any idea about this? Some of the incoming, no. Some of the incoming, some minus some of the outgoing. That's absolutely wrong concept. Anybody else? Try to participate. Vertical, horizontal forces. Very, very good. Because I told you that in the note number 1, I mentioned that whenever the two forces are acting perpendicular, the moment two forces are acting perpendicular, suppose that horizontal force is Fx and vertical force Fy. The name I am given different. I have given the name F1, F2. Suppose that the same name I am giving right now also. And suppose they are making the angle 90 degree. Then I mentioned that the formula will become very, very simple, right? Just take Fx and Fy. That's it. That will be your resultant force, right? Now, when you have the multiple forces, then what you do, try to fall. Suppose that it is making an angle theta. This is also making an angle theta. This is also making an angle theta. This is also making an angle theta. Suppose that all are making same angle theta, theta, theta. Then what you do, you try to follow the component of x component of this force and the y component of this force, x component, y component, x component, y component, again x component and y component. And what you do, just take the summation of all the forces along the x direction, or we can take summation of all the forces along the horizontal direction, and you take the summation of all the forces in the vertical direction, something like this. Once you just find these, all these particular, based on the direction, suppose that this is coming positive, this is also coming positive, suppose that. So your summation of all the vertical force will be what? In this direction, because of positive, and all the horizontal force will be what? In this direction, like this. Then what you can do, can't you find the resultant now? Then what will be the formula? Then what will be the formula, my dear friend? Is it not the formula will look like something like this? Tell me, guys. We just got the idea from the note only, note number 1 that we have discussed after discussing the resultant formula. Yes or no, guys? Check it out. Any difficulty in this particular resultant formula? When we have the multiple forces which are acting on a particular body, then can't we have this particular resultant formula? Check it out. All of you, please check it out. Right? So these are the basic idea that we are developing from this particular resultant of the forces, right? So it's a very, very important thing. And of course, when I talk about the mechanics, engineering mechanics, so engineering mechanics is basically the branch of two things. First is what? Statics, then we have the dynamics, right? Statics, then we have the dynamics. Static means we are studying the what? The body under the rest conditions. We are studying about the body which are under what? Rest condition. In the dynamics, we are studying about the what? Motion of the body, right? In that also we have the two categories. One, we have the kinematics, other is what? Kinetics. Again, in the kinematics, we have only velocity and acceleration without consideration of the forces, because you know that forces and the movements are responsible for the motion of the body. Yes or no, guys? All of you are understanding which what I'm talking about? First of all, tell me whether it is clear or not. All the things which I have written over there, all of you have noted down? Tell me, guys. All of you have noted down? Perfect. Now, note on the next concept. The resultant of the force system or multi-force system, multi-force acting on a body. Note on this topic. This is a very, very important topic. Now, Suppose that we are taking on a particular body. Suppose that body is there. On a body, I'm just taking the coordinates 0, 0. This is x-axis and this is y-axis. And let's suppose that this is minus and this is what minus y. And suppose that the number of forces are acting something like this. F1 forces are acting like this. F2 forces are acting like this. F4 is acting like this and F3 is acting like this on a particular body, or maybe particle you can take, right? So what you do, and now take the angle also. Angle is very, very important. You can take alpha, beta, gamma, delta. Now, if you just want to find the resultant of all the forces, what I'm asking, the resultant of all the forces that are acting on a body. Suppose body is A. The name I'm giving the body is what? A. Now I need to find the resultant. Resultant means R. How we can find? Just find the resultant, first of all, the summation of all the forces along the horizontal direction, right? So what I'm just doing, I'm just finding the summation of all the forces along the horizontal direction like this. This symbol is what? Summation. Those who are not understanding, please let me know, right? I'm believing that some of the things you already know, right? So that's why I'm skipping. If you're not aware of anything, just let me know. Understanding or not? All of you. All of you are understanding? Because once we discuss the very high level numerical, then you might be facing some difficulties. That's why I'm saying that before only you just try to ask me each and everything, right? Now, summation of forces along the horizontal direction. What about the forces? See, forces F1 is acting what? In this direction, like this. I'm just drawing the force F1. And this is making an angle alpha with the horizontal direction. Then what about this component? F1 cos alpha. And what about this component? F1 sin alpha. Then what about the horizontal component of F1? Can I say F1 cos alpha? Positive or negative? Positive or negative? Positive, right? What about the horizontal component of the force F2? F2 is what? F2 is acting what? In this direction. And this is making an angle what? Alpha, a gamma. Now, what about this particular component? F2 cos gamma. And what about this component? F2 sin gamma. Now tell me whether I should write minus or plus. Plus or minus in this one. F2 cos gamma. Minus, because it is acting what? In the negative direction. Force is what? Vector quantity. We need to write magnitude as well as what? Direction, my dear friend, right? Very, very important. What about the component of the force of F3? I'm writing over here also. F3 is what? Acting like this. And now it is making an angle what? Delta. So what about this component? F3 cos delta. And what about this? F3 sin delta. Sin delta, sorry. It's a delta one. If anybody do not aware of resolution of the forces, then also please let me know. See, suppose that any force is acting like this, right? F3 is also negative. F3 will also be negative, minus F3 into cos delta. And of course, F4 will be positive. F4 cos beta. Now, forget about this thing. Some of you, I know that having doubts are how this horizontal component will be cos of that force, and what about the vertical component, sine of that force. But how it is that? Now, let me just show that. See, what about this angle? Suppose that theta. This angle is what? Theta. Now, you just want to find the vertical component of the force and horizontal component of the forces. What you know? Cos theta. What you can write? This is making an angle theta. What about the cos theta? This component, which I just want to find, x component divided by what? Divided by f. So can I say fx will be f cos theta. And similarly, can I say sin theta will be equal to f vertical component fy divided by what? F. So can I say f will be equal to fy will be equal to f sin theta? Is that clear how I am writing something like this? Tell me guys. Now it's clear how we are writing these components. Some of you who are having doubts whether it's clear or not. Tell me guys. Right now, do not hesitate. Each and everything will be clear over here. Right. I know that the time will be less. Right. The time allocation will be less, but believe me, each and everything will be clear once you ask the doubt. Right. Now, summation of all the forces in the y direction, or maybe you can say that summation of vertical forces. How we can find? Now tell me, F1 component in the y direction, positive or negative? F1 sin alpha minus F1 sin alpha or plus F1 sin alpha? Plus. Very good. That will be plus. What about this F2? F2 will be plus, right? F2 into sin gamma. What about F3? What about F3? Minus. Minus, because acting in the what? Downward direction. Sorry. It is acting in the downward direction. Minus F3 into sin delta. Minus F4 into sin beta. Now, once you got to know the horizontal component of the force and the vertical component of the force, now you know that resultant. How to find the resultant? It's a very, very easy thing, right? Summation of horizontal forces plus summation of vertical forces. Because you can consider this to be what? One type of force P, and you can consider this to be what? One kind of force Q. And you know that when the two forces P and Q, suppose that it is coming to what? In this direction, and it is coming in this direction. Now you can find the resultant, because you know that whenever the two forces are acting perpendicular to each other, then what is the resultant formula? The resultant formula will be P square plus Q square. The same thing is what over here. Please note down. And my dear friend, what about the tan alpha? What about the direction of that resultant with the horizontal? What about the direction of that resultant? What about the direction of that resultant? Tell me guys, what about the direction? Can I say summation of vertical forces divided by summation of horizontal forces? Check it out. Please check it out. Yes or no? All of you, please let me know. Vertical by horizontal, and that is also by default, it's a very accurate thing, because what about tan alpha from this triangle? What about tan alpha? Q by P. Q by P. And what about Q? I have taken Q to be what? Summation of vertical forces. And what about P? I have taken P to be what? Summation of horizontal forces. Right? Please note down. Very, very important thing. Is that clear? All of you are understanding each and every point? So today's topic will be the resultant of all the force system. In fact, we are going to discuss different types of force system also. Collinear, coplanar, non-concurrent, non-coplanar, all this kind of force system, 2D force system, 3D force system, right? So these are the things that we are going to cover today. Yes or no, guys? All of you are understanding? Yes? Now, once it is done, please let me know. Once it get over, all of you, once it is all of you have noted down, then please let me know. Done? Is it done? Done, right? All of you? Because maybe it may be possible that some of you have noted down, but some of you is still noting down. So that will be the, of course, the PPT will be shared because whatever the slides are there, that will be shared, but still. Okay, fine. Now, if that is clear, then you please try to solve this numerical. The four forces are acting of the magnitude 20 Newton, 40 Newton, 60 Newton, and 80 Newton, respectively, along the four sides of the square ABCD. What about the magnitude of the resultant? They're not asking the direction, right? They're asking what is the magnitude of the resultant. That has been asked in ISRO 2016, right? Now, why I have taken the question from the ISRO, that is also one valid reason is there, right? Some of you might be thinking that there is no correlation between HAL examination and ISRO examination. I know that. But in ISRO also, you have the 90-minute and 80 question. So hardly you have 1 minute of time for each and every question. And suppose that 1 minute of time is there, then you know that what is the level of the question they are asking. And now you know that in HL also we have 1 minute of the time. So that you can correlate what can be the question can be asked. Suppose that the question has been asked from the engineering mechanics, what type of question that can be asked, right? Now try to solve this numerical. Square body is there, or maybe you can take this particular square shape ABCD. It may be the frame, it may be any body, right? And along the each side we are what the four forces that are acting in the different directions, different directions. What about the magnitude of the resulting force they are asking? So any answers? A, B, C, D, what is the option? Take your time, but try to solve accurately. Of course, in HL examination, one more thing, there is a no negative marking. There is a no negative marking, and cutoff for last year was 121 out of 160. I'm talking about the cutoff for HL examination was 121 out of 160. So now you can calculate, my dear friend, you can just calculate the percentage. At least how much of percentage unit is score? 76%, right? So you don't have that much of, luxury to leave the question, right? Now, I just got the answer from very few guys. I just need the more answer. Tell me guys, only 2% getting the answer or what? Yes. Tell me guys. First of all, find the net vertical force. See the solution. How many of you are not getting the answer? Tell me. How many of you are not getting the answer? Tell me guys. Hello, hello. All of you can hear me? How many of you are not getting the answers? Tell me guys. Okay, fine. Try to find the net vertical force. This net vertical force I'm calling what? Summation of FV in the vertical direction. Either you say FV or you say FY, both are same thing. What is the total force that are acting in the vertical direction? 40 plus 40 minus 80. Then what about the resultant force? Minus 40 Newton in the downward direction. So what we can say, total force is what? 40 Newton in the downward direction. What about the net horizontal force? What about the net horizontal force? Summation of horizontal force plus 20 minus 60. Then what you can find? Minus 40 Newton. Or what you can take? What you can write? 40 Newton in this direction, right? Because force magnitude along the direction that we need to mention, right? Now, so what is the total force? Now the resultant force is what? Summation of forces are acting in this direction, and summation of FH will be acting what? FV is acting what? In this direction. Then what about the resultant? The resultant will be somewhere here. Sorry. It is also in the downward direction, right? It is also in the downward direction. It is also in the downward direction because negative one, right? Minus 40, minus 40, both are what? Minus. So the resultant will be, so the resultant will be somewhere here. This will be the resultant. That is what making an angle alpha. What about the resultant? Summation of FV whole square, summation of FH whole square. Then what we can get it out? Minus 40 whole square, minus 40 whole square. Then what you are getting? 40 into under root 2. A option is correct. All of you are getting my point? Naveen, are you getting? Perfect. Right. So these are the level of the question, right? In fact, we are not, even started the topic, but we have seen the many questions, right? Many questions in the sense we are just seeing the question from each and every topic. Now, some of you might be thinking, sir, you just started in engineering mechanics like anything from the resultant, but you're not giving any idea about the engineering mechanics that actually what actually we are going to do in that. So for that also, let me just give you some overview about that topic, right? Engineering mechanics. So first complete this numerical, then we can discuss. Once it is done, please let me know. Done, all of you? I think done, right? Now. So let me just give you a brief introduction about this engineering mechanics. Because some of you might not be feeling comfortable, sir. You directly started the resultant one, right? Now, let me just relate that resultant with the engineering mechanics. Why I have started that? Engineering mechanics. So engineering mechanics we broadly classify under two categories. One is what? One is statics, and the other one is what? Dynamics. When I say statics means what? Under the rest condition. Yes or no, guys? Dynamic means in the broad sense, you will come to know, sir, there is a motion. Yes or no, guys? Tell me, guys. Yes or no? Now, under static, when the body is under rest condition, then we have to discuss about the forces and movement. Again, I have discussed about the forces. But sir, you have not discussed about the forces definition. What is the force definition? Anybody? Can you please tell me? Sir, you are talking about the force, but you have not given any definition for the force. Right? I am just again telling, once again, we will go from very, very basic level, 0 level to the top level. Suppose meter is what? From 0 to 100, right? So suppose I'm over here right now. Once I reach to the what? Near to the 100, then I just want all of you guys to answer all the question. At that time, you should not be saying that, sir, I'm not getting any answer, right? So that's the reason I'm discussing from what? From this level to what? This level. If I start talking from this level, you will not understand the things, right? Now tell me the very one-line definition for force, if you know this. Definition. If I just say, because that is also one important thing. Tell me, guys. Yes. Now tell me, guys. Yeah, it is a physical quantity, note down. It is a physical quantity which acting on a body, which when acting on a body tends to change the state of the body. It is a physical quantity which when acting on a body tends to change the state of the body. If I say state, what do you mean by this state? State means this thing, either in the rest condition or in the motion condition, right? Yes or no, guys? It is a physical quantity which when acting on a body tends to change the state of the body, right? From the Newton's second law. Anybody know the Newton's second law? Anybody know the Newton's second law? Tell me, guys. All these things are, you might have studied in the 12th standard or 11th standard. Tell me, guys. From Newton's second law, what we can understand by the Newton's second law? Yes. Force will be equal to m into dv by dt. Rate of change of momentum. Rate of change of momentum will be equal to what? Forces, right? And we know that force will be equal to what? M into A. So from there, from the Newton's second law, we got the idea of the forces that are acting on a particular body. When this particular forces will be zero, then what we say? The body is under rest condition or in the motion condition? What we can say? The body is under rest condition or in the motion condition? Always rest condition. Or let me just ask you one question. Inertia. What do you mean by the inertia? Inertia of the object will be, suppose that any body is under completely rest condition. The body is what? Completely under rest condition. Then that body will remain under what? Just want to be remain under what? Rest condition throughout its life. That is also one type of inertia. Or suppose that the body is moving with some what? Or the body is what? Body is moving with some constant velocity. So there is a misconception, guys. What is the misconception? Try to understand. What is the misconception? If somebody is saying that the net force on a system, the net force on a particular system is zero. Suppose that if somebody is saying that the net force on a particular system is zero, then they are saying that the body is under what? The body is under rest condition, whether it is correct or incorrect. Whether it is correct or incorrect. Tell me, guys. See, when net force on a particular system, when I just say force, I just talk about the net force. When net force on a particular system is zero, the body is what? Under rest condition. But it may be possible that when external force is zero, then mass into acceleration will also be zero. Mass cannot be zero, but acceleration will be zero. When acceleration will be zero, my dear friend, it can be zero under two cases. When dv by dt will be zero, that means when dv will be zero, or we can say that the body is moving with some what? The body is moving with some constant velocity. So when the body is under motion, then also the net force can be zero when body is what? Moving with somewhat constant velocity. That is what the inertia, right? Tell me, guys. So under these two conditions, no force involved. Under these two conditions, no force involved. Right? This is a very, very fundamental thing, guys. And that may be asked in many interviews, right? Please note it down. Some of you always say that when the net force is zero, the body is what? Directly under rest condition. It's not completely true. When the body is what? Net force is zero, I'm saying that the body is under what? Equilibrium conditions. That is what our next topic. What is the first topic? The resultant of all the forces. The second topic is what? Equilibrium of the forces. Or equilibrium of the what? Bodies. Right? Please note it down. Of course, we are talking about the static, that is force and moment. And then we have, equilibrium. And then we have trusses. And then we have, that's it. In the dynamics, what we are going to have? In the dynamics part, what we are going to have? Two things. That is also broadly classified under two categories. The first one is what? Kinematics. And then we are going to have kinetics. Kinematics and kinetics, what is the difference between these two? Both are under classified in the dynamics, but what is the major difference? Now we have the force involvement over here in the kinetics, but here in the kinematics, there will not be any force involvement. Only we are going to study the motion. Only studying the motion. That's it. We are only studying the motion, that is velocity, acceleration, and what? Alpha. Angular acceleration, velocity, acceleration, and alpha. That's it. What about the kinetics? Here, along with this V, velocity, alpha, and acceleration, we are going to study about what? Forces as well as torque. Understanding or not? Yes or no, guys? Perfect. Please note down. So these are the broad classification of the engineering mechanics. So some of you might be thinking, sir, why we are studying the resultant of the forces? That is our first topic. Second topic will be equilibrium of the forces, right? Again, sorry. And the fourth topic we are going to have the friction. Friction. Please note down. Now, once it is done, please let me know. All of it done? Is it done, all of you? Okay, fine. Now we have to discuss about the, the concept of force system, types of force system. Note down the types of force system. The types of force system. How many types of force system we have? We have multiple types of force system. First is coplanar. In the coplanar, we are going to have the first category, coplanar concurrent force system. I will tell you what is the meaning of coplanar and concurrent, all kinds of stuff. Coplanar concurrent force system. B will be coplanar, non-concurrent force system. Then we are going to have the third one, coplanar parallel force system. And then fourth one we are going to have coplanar non-concurrent and non-parallel force system. So this is our in GATE syllabus. These are there in the GATE syllabus. But when you just talk about the non-coplanar force system, so in this one again we are going to have the category similar, non-coplanar, concurrent force system. Then B option will be what? Non-coplanar non-concurrent force system. Similarly, we have the different kinds of category. So these are there in the basically what? ESC syllabus as well as IAS syllabus, right? When you're going to write the mains examination, then you are going to see the question from this particular non-coplanar. What is the meaning of coplanar and non-coplanar? Whenever all the forces are acting in a particular single plane, then we say it's a coplanar force system. All of you are understanding what I'm talking about? Tell me, guys. All of you are understanding? When all the forces are acting in a single plane, suppose that right now you are in front of the laptop, right? In the laptop, your screen, when all the forces will be acting on your screen only on the screen, then it's a single plane. That is called coplanar force system. But sir, you will ask me, sir, what about this coplanar, concurrent, non-concurrent, and all kinds of stuff? So let me discuss one by one, right? What about the coplanar and concurrent force system? Example. Suppose two plates are there which have been joined together with the application of cover joint, something like this. In machine sorry. In machine design, you will come to know about the butt joint, lap joint, right? And design of those joints, that you will come to know in machine design. So in that also we are going to study, these kind of things. Two plates are joined together with the help of what? Rivets, right? And we are just applying the force, something like this. So, sir, why you are drawing this thing? You will ask me, sir, why you are drawing this particular thing? Why I'm drawing in the sense means, try to understand. What about the line of action of the force? Line of action of the force for both the forces are same or different? Line of action of the force are same or different? Line of action of the force means when you just pass the line from the forces, whether they are meeting at a particular point or not. Yes, they are meeting at the particular point. They are on the same plane. Then we say it's a coplanar concurrent force system. Please note down. Right? In many PSU we have come across, what we have come across, they are asking the example of the coplanar concurrent force system. Can you please tell me example? Can you please tell me the example? I already mentioned. Tell me, guys. What is the example? See, they are not asking directly the question. They are asking what is the definition. That is also they are not asking. They are asking that directly 4 options they are giving, and they will just check it out from you that whether you know about the coplanar, concurrent, non-concurrent, parallel system or not. So the example is what? Double cover, butt joint. Simply just remember butt joint, right? That is the example of the coplanar concurrent. In fact, we can just find, can we say collinear also? Coplanar, collinear force system. Sorry. Can we say coplanar, collinear force system? Collinear means all the forces are meeting at a particular same line, then we say it's a collinear. So in fact, over here, they are meeting at the same point. They are meeting at the same point. Apart from that, they are on the same line. So still we can say that coplanar concurrent and coplanar collinear force system. Understanding or not? All of you are understanding what I'm talking about? Perfect. Now, can you just tell me the example of the coplanar non-concurrent force system? Once it is done, please let me know. Once it is done, please let me know. Done, all of you? Is it done? Perfect. Now, just wait. Yeah. Is it done, all of you? Can I move to the next slide? Can I move to the next slide? Yes. Perfect. Note down for coplanar non-concurrent force system. You might have seen the lap joint. You might have seen the lap joint. There the forces will be what? Not meeting at a particular point. Whatever the forces we are applying, they are not meeting at a particular point because they have some eccentricity. They are not meeting at a particular point. Check it out. Right? When they are not meeting at a particular point, because when you just extend the line of action, they will never gonna meet. When they are not going to meet, then what we say? Coplanar non-concurrent. Concurrent means, just remember, meeting at concurrent force system means when all the forces are meeting at one point. When all the forces are meeting at one point, then we say it's a concurrent force system. So here we say coplanar, both are in the same plane, but they are non-concurrent. Coplanar non-concurrent force system. Remember, I'm just once again, I'm telling that they are not asking the definition, right? They are asking the example, and examples are butt joint, lap joint, right? So they are asking just one level above what the general studies are there, right? Lap joints. See, concurrent means when all the forces are acting at one point, one point. This is a concurrent. F1, F2, F3, F4, F5. When the two forces are meeting at one particular on the same line, F1, F2, one more force, F3. But the line of action of all the forces are what? Similar on the same line. Then we'd say it's a collinear. Is that clear, the difference between this collinear as well as concurrent? On the same line, collinear. On the same point, concurrent. That's it. Yes or no? Tell me, guys. What you are asking, sir? So last example was collinear. Yes, collinear, right? See, last example, not only along the same line, but meeting at the same point. So it is what? Concurrent as well as collinear, both. Yes or no? What's your name? Let me just check it out. Clear whether it's clear? Prabhakar. Praveen, you asked the doubt whether it's clear or not. Clear, right? See, why? See, transmissibility, very good. The principle of transmissibility means we can just extend the line of action of the force anywhere on the point. See, the force are acting on this plate. Let's suppose that F1, and the force is acting what? F2. By the principle of transmissibility, we can just extend the line of action of the forces like this. Like this. Now tell me whether they are meeting at a particular point or not. Tell me, guys. Whether they are meeting at a particular point or not. Now it's clear, Praveen. Done. Can I move to the third category? Can I move to the third category? Coplanar non-concurrent force system. So this is the one type of example. What you're saying? So all the collinear forces are concurrent. Yes, you can say. But all the concurrent forces are not collinear, right? But all the concurrent forces are not collinear, right? Yes or no, guys? Now, one more example is there, coplanar non-concurrent force system. Can you please tell me example? Any one of you, can you please tell me the example? When you just take the beam, the beam has been supported by the roller support and the hinge support, suppose that, and we are applying a lot of forces, suppose that the force F1, force F2 and force F3. Now all the forces are not parallel and they are not meeting at a particular point. When you join the line of action of the forces, they are not meeting at a particular point. Sorry, what is happening? Yeah. On a particular body, this is the beam. On a beam, they are not meeting at one particular point, neither they are parallel. So can we say coplanar non-concurrent non-parallel force system? And what is the example? Can we say beam? Can we say all the beams? Tell me, guys. Or let me just take you to the point, not all the beams, some beams. Because in some beams, we have the parallel force system also. Yes or no, guys? All of you are understanding or not what I'm talking about? Coplanar, non-concurrent, non-parallel force system. Now, one more is there. Let's suppose that the beam is there. Let's suppose there is a beam. Let's suppose there is a beam. And what we can have, the simply supported beam you can take, the hinge support, and there is a roller support. I will discuss about these supports, do not worry. Now the forces are acting something like this, F1, F2 and F3. Now all the line of action of the forces are what? Parallel to each other. Then what we say? Coplanar parallel force system. Please note down. Now tell me, anybody know about the truss? Anybody know about the truss? You heard the name truss? Then what is the difference between beam and truss? What is the difference between beam and truss? Tell me, guys. Truss has a many member or multi-member, and beam is what? Single member. Very good. The beam is single member and the truss is what? Multi-member. Now tell me, The truss can be classified under which category? Coplanar, non-coplanar, or coplanar, non-concurrent, non-parallel force system, or what? When I just take complete truss, it can be come under which category? Coplanar, non-concurrent, non-parallel force system, or something else? Try to think and tell. Try to think and tell. Very good. So trusses will also come under this category. Right? Note down, very, very important. Coplanar, non-concurrent, non-parallel force system, truss will also come. Because if I just talk about the truss, it will be something like this. Just keep on repeating the triangle and you will get what? Truss. Just keep on repeating the triangles, you will get what? Truss. F1, F2, F3. So neither forces are parallel, non-concurrent. They are not meeting at a particular point, right? Suppose that these are meeting at a one particular point, but this particular force and this force, they are not meeting at one point. All the forces must meet at one point. Then only we can say that concurrent. Otherwise, no. Out of the three forces, no, truss always we just find that it is made up of triangles. I will tell you the reason for that also. A perfect truss is generally made up of triangles, right? Why there is not a square rectangle, that I will discuss, right? Stability will be important for in case of what? Trusses, right? When we discuss the third chapter after the friction, there you come to know about the importance of the designing of what? Trusses, right? Done, all of you? Is it done? Let me just ask you one very simple question. The fluid through a parallel pipes will be which type of force system? A fluid is flowing through a parallel pipe will be the example of which type of forces? That is a very simple question I'm asking. Try to think and tell. The fluid is flowing through a parallel pipe. I know that it might be very difficult to digest that. So you're talking about the body. Now you're talking about the moving from solid body to fluid body. How it is that? Yes, everything is possible. Try to categorize. A fluid is flowing through a parallel pipe represent which type of force system? At least just tell me whether it's a coplanar or non-coplanar. How can you say it's a coplanar? Tell me. How can you imagine that the fluid will be flowing in a particular plane, like a paper? The fluid will be flowing, suppose that in a particular XY plane or XZ plane, then how can you say it's a single plane system? It's a three-dimensional, right? See, the fluid is flowing through a pipe, suppose that. Then you can't say that the forces are acting, maybe fluid forces are acting on one particular plane. No. One force is something like this. Suppose that in this plane, other force will be acting what? In this plane. Other forces are acting what? In this plane. So it's a non-coplanar. First of all, very good. Idea is what? Non-coplanar. And all the fluid forces are what? Parallel. Suppose that. So it's a non-coplanar, non-concurrent force system. All of you are understanding or not? Suppose that some of you are not getting any idea. So what is the meaning of non-coplanar force system? So for those guys, let me just give example of cubical element. Cubical element. Suppose this is X plane, Y plane, Z plane, X axis, Y axis, Z axis. One force is acting like this. Another force is acting what? In this axis, suppose. And one force is acting what? This. So this is a non-coplanar. Non-coplanar. Right? And non-concurrent force system. And the similar thing is happening what? Just replace this tube with the what? Pipe. That's it. All of you understanding or not? Try to imagine in a 3D way, right? Not in a 2D figure, right? Whatever that you are seeing on the laptop screen, it's a two-dimensional. That's it, right? So coplanar force system we also call two-dimensional force system, and non-coplanar is what? Three-dimensional. This can be solved analytical, but this can be solved only by what? Matrix and vector. Very, very big vectors and matrix you will be getting for solving this non-coplanar force system. And of course, that is not possible less than 20 minutes or 30 minutes of the time. So there's no chance that they will give the question from this zone. Definitely, they are going to frame the question from coplanar, that is from that whatever the syllabus is there in the gate, that is going to be asked, right? All of you are getting my point or not? Actually, these are the very silly things, right? Even I would have not discussed this thing. You must be getting idea about all this force system, but still I'm discussing so that some of you will be feeling the subjects are actually what is actually happening, right? Because once I start dealing with the equilibrium of the system or equilibrium of the force system, then suppose that if I'm doing summation of horizontal force is 0, vertical force is 0, and movement is also 0, then you should not confuse at all for different force system, right? Now, let me just note down the third concept. Note down the concept. What do you understand by movement? Anybody please tell me what do you understand by the movement? Movement means movement of forces. This we also call torque. Tell me guys, what do you understand by tendency of the force to rotate the body? Perfect. That is a very good definition. Other thing. So what we can just write the similar thing what he has said, the rotational effect of force, the rotational effect of a force is called as movement of the force. But my dear friend, the definitions are not only important, we need to remember the formula also. We need to remember the formula also. Suppose that there is a body which is hinged. So right now, please forgive me that I'm not discussing anything about the support. Just try to remember that we are just talking about the hinge support. Now there is a member which is being connected something like this. This is the hinge support. Now we are applying the forces like this. Suppose that. Now we are applying the forces like this, which is perpendicular to this one, which is a perpendicular to this one. Suppose that, right? And the length is what? L. And the length is what? L. Suppose that the length is what? L. My dear friend, the torque or movement, what we can write in a vector format, R cross F, right? R cross F, or we can just take the this particular thing, something like this, so that you will be getting a complete idea about the vector. Believe me, if you just go through the vectors are very, very important, right? Once you have the basic understanding, you can solve the velocity and acceleration concept. Not only in the mechanics, in theory of machine also, we will be having velocity and acceleration. Then there also you can just play with the topic, right? Suppose that the body is something like this. This is the position vector R, and this is the x coordinate. Suppose that, and we are applying the forces like this. Now, when you try to resolve, what I will be getting? RF sine theta, right? Right. So this is the magnitude I'm getting. Torque or the movement. Now tell me what will be the direction. What will be the direction of the force that is generating the movement? Tell me guys. No, man. Direction means you are not understanding. When you try to extend this line, suppose this line is making an angle what? Theta. Suppose that. This angle will also be what? Theta. Suppose this is the R vector. and this is what the 90° we are going to have, then what about this r sine theta? What you are getting? R into F, F into r sine theta. That means what? What about the direction? What about the direction? What about the direction? Tell me, guys. Perpendicular, right? Yes or no, guys? It's a perpendicular. Yes or no, guys? Perpendicular to the hinged point. Or you can say that perpendicular to the body. The force direction will be perpendicular to the body, right? So remember that whenever you have any forces, suppose that any body is there, this body is there, suppose that, and you are applying the forces like this. Somebody will ask you, and the length is what, 2 meters, suppose that, and it is making an angle theta 45°. Now, if somebody will ask you, what is the movement about point A? Suppose that somebody will ask you, what is the movement about point A? Then what you will answer? Whether you will answer F into distance 2 meter, option A. Option B, you will just answer, suppose that you will try to resolve this one, or maybe you will be getting the answer, suppose that, like this, theta. So F cos 45 into 2 meter. C option will be F sine 45 into 2, and D option, none of the above. So what is correct option? Movement. There is a rotational effect of the forces is called the movement. But to have the rotational effect, my dear friend, you need to apply the force perpendicular to the body. Perpendicular to the body. Right? This force will not be able to rotate this particular body. Right? But this component of the force which are there, and this component, out of this component, what about this F1? And let's suppose that F2. Now, if I resolve from the engineering mechanics, suppose that this is the X coordinate now, and this is the Y coordinate. So apart from that, if I just take it out, then what I'm just calculating, this will be 90 minus theta. So what about this component? F sine theta. And what about this component? F cos theta. So whatever the component that will be perpendicular to the body, that will be responsible for rotation. Can you just imagine? Can you just imagine about this point, hinge point A, about this particular hinge point A, this body will be try to rotate by the application of the force F1. Tell me, guys, understanding or not? All of you are understanding or not? So what is the correct option? F cos 45 into 2. Somebody will just argue with me, sir, F sin 45 is also same thing, right? But what about the theta? If theta is there, then if theta is other than 45, then a very, very important thing, right? Please note it down. So whatever the moment or torque that will be generated, for that we need to apply the forces perpendicular to the body. That's it, right? Now, if I just ask you the thrust one, what do you understand by the thrust? In a very simple term, if I just ask you about the thrust, what you will say? The force which are acting along the length of the body, or towards the length of the body, or towards the hinge point. Can we say it's a thrust force? The force acting along the length direction and towards the joint, towards the fixed point. Can we say it's a thrust one? Tell me, guys. Sorry. Yeah. Can you just say the difference between movement and thrust? All of you are understanding or not? My point. The force which is responsible for rotation, that must be acting perpendicular to the body for generating the movement, for generating the rotational effect, for generating the torque. Yes or no, guys? Right? Suppose you are not understanding, you can take the example of this circular object. Suppose that this is the hinge point. Now suppose that if you just want to rotate this body, a point, right? Suppose that this body is there. If you just want to rotate it on a circular object, what you do, just apply the force in this direction, perpendicular to this particular direction. Then only it can have the rotational effect. Otherwise, no, it is not possible. Suppose the body is what, in this direction, apply the force in the what, perpendicular direction. But to have the thrust force, to have the thrust one, the force must be acting along the length direction, along this direction. So now if I just ask you, what is the thrust in this one, in the same object, in the same figure, what will be the answer? What will be the answer for thrust one? C. Very good. Sorry. Yeah, please note down. Very, very important. Is it done, all of you? Is it done? All of you have done? Now try to solve the numerical that has been asked in the Gujarat Public Service Commission. In the Gujarat Public Service Commission, they have asked one question. They are asking, what is the calculate the resistant torque for a static equilibrium condition in the following figure? Tell me, guys. Now, do not worry about the statement of the particular question. Do not worry at all. Whatever the statement they have mentioned, resisting torque. I will discuss about the resisting torque and I will discuss about the static equilibrium condition. Forget about these two terms. Just try to find the torque about this point A. That's it. Still, we are in the chapter number 1 and still we are discussing the topic called the resultant of the forces and the force system. We are yet to cover the syllabus called static equilibrium conditions. That I will mention, do not worry. But still, I'm just asking you the torque, that's it. Torque about A. So in this question, I'm just asking you the torque about A. So now, this is the body. And this body, the force is acting like this. Now there will be two component. Now there will be two component, my dear friend. Sorry. There will be two component, something like this. And this component of the force will be, this is theta. This will also be theta. I think we did mistake. Sorry, in taking the angle, we did mistake, guys. Here, my dear friend, whatever the angles are there, this is 90 minus theta. This is a theta. That is the correct thing. This will be the theta. So this will be, f cos theta, and this will be f sin theta. Please make the correction over here. Please make the correction. So this option will be correct. F sin 45 into 2 will be the answer for moment. Sorry, will be the answer for moment, and this B option will be the will be the answer for this one. Please make the correction. And for the moment, option A. Sorry, option C. Understanding or not? All of you are understanding? Yes or no? Yes or no, guys? See, try to imagine, right? Yeah. Now, similarly, here also what we can have? Similarly, here also what we can have? Suppose that this is the x component and this is the y component. So we can now resolve the forces something like this, and the forces are acting the forces are acting something like this with making angle theta. So this component will be F cos theta and this component will be F sin theta. So this will be what? This component will be F sin theta and this component will be F cos theta. F cos theta will not be responsible for the torque. F sin theta will be responsible, which are acting perpendicular. Force into distance, that will be the torque, right? So what about the torque? F sin, what is the force? 20. What is the sin theta? Sin 30 into what? 30. Then what will be getting? So 300 Newton centimeter. D option is correct. Check it out. All of you are understanding or not? Right? Please note it down. Now, shall we discuss about the equilibrium of the force system? What do you mean by the equilibrium? What do you mean by the equilibrium of the force system? Tell me, guys. Balanced out, right? A very simple term is balanced out. The net force should be zero. Net movement should be zero. Remember that any body will be called as under the motion condition when it is translating or whether it is rotating. Suppose that a truck is there, right? Now it is translating. That is also under motion. Or object which is what? Being under what? Rotation. That is also under motion. So the summation of all the forces must be zero and summation of all the movement must be zero. Then only these two conditions will together satisfy the criteria for static equilibrium conditions. Do not worry, we are going to discuss in detail about this thing. As of now, just note down in short. In short, summation of all the forces along the x, along the y, along the z. Summation of all the movement about z axis, about x axis, and about y axis must be zero. That is called as static equilibrium conditions. Please note down. That means we are talking about, we are talking about the body under the rest condition. Right? So whether net force is zero or net movement is zero. So two things are basically what? Generating. Whether it may be possible that when the net force is zero, it may be possible that the body is under what? Rest condition, or it may be possible that the body is what? Under uniform motion. Yes or no, guys? I discussed this thing in detail, right? When acceleration is zero, you have the two things. Check it out. When acceleration is zero, you have the two things. Either dv will be zero, maybe what? Change in velocity is what? Zero, because the body is what? Moving with the uniform velocity. It is now never going to change the velocity until unless you are applying the forces. Or it may be possible that, both the velocities are zero. u1 and u2 are zero. In that case also, du will be zero, and du dt will be zero, and acceleration will be zero. Right? So there's a two possibility. When I just talk about the static equilibrium condition, means I'm talking about the inertia condition. The body may be under rest condition, or it may be possible so that it is moving with some constant velocity. Are you getting my point, what I'm talking about? So some of you who are in the worlds of only the rest condition, they might not be knowing these conditions. Yes or no, guys? Right? So please remember, these things are very, very fundamental thing, basically tested in the interview, right? When you just attend the BARC interview, right? Or ISRO, or DRDO, or HAL, the things will not be simple. I agree that the clearing the examination will give the 85% weightage, but 15% you simply cannot ignore. In fact, it is only there in the HAL examination. But if when you just go to the ISRO, 100% weightage to the interview, Park, 100% weightage to the interview. DRDO, it is there in the cutoff weightage. Suppose that interview is for 100 marks, 70 marks will be required to qualify at least for the final selection, right? Suppose that you have written the GATE examination, after that you have written the descriptive examination. After clearing the examination, suppose that 600 marks is there and you are the topper, 500 marks, but in interview you are getting around 50 marks or 58 marks. You are not qualified. You will not be in what? In the final list, because you are getting less than 70 marks. But in HL examination, only the weightage is what? 15%. But that doesn't mean you simply go to the interview panel and they will simply ask you what is the meaning of what you say laminar flow, or maybe what is the meaning of fluid solid. No, it is not going to happen. Suppose you mention your favorite subject as strength of material. The moment you mention design subject, now they will start playing like anything from the fundamental to the what? A very high level things, right? So please stick to the what fundamental thing has been discussed in the class, right? Yes or no, guys? Done? Can I move to the next slide? All of you done? Perfect. Now, let me discuss about some of the concept of equilibrium of the system. Now, note on these particular slides, and of course, the time is already over. We'll discuss more 5 minutes, and then we can close the session. Now, note down, a body is said to be in the equilibrium if it is a state of rest, if it is in the state of what? Rest or under uniform motion in a straight line is not altered, right? That particular body is said to be what? Under equilibrium conditions, right? Now we have to discuss about the equilibrium condition of all the force systems that we have discussed: coplanar concurrent, coplanar parallel force system, coplanar non-concurrent, non-parallel force system, how we can maintain the static equilibrium conditions, right? Those are the very, very important thing. Now, suppose that we are talking about the rest condition. Suppose that we are talking about the rest condition or uniform condition, then the net force, according to Newton's second law, the net force must be 0. And what about the net moment? I alpha, that also must be 0. Both are Newton's second law. Remember, this is for translating motion and this is for rotation motion. Once we discuss about the concept of dynamics, when we enter into the chapter called dynamics, there we can discuss in detail about all these things, right? As of now, just note on the few points about that. Now, whenever we are talking about the body to be in rest condition or uniform motion condition, remember net force must be 0, net moment must be 0. Now, again, you will confuse. Coplanar concurrent force system, do we need to balance out net moment to be 0 or not? Is it very, very mandatory condition? Let me ask you a question. See, first of all, note down this thing from here to here, and then you please note down this particular section from here to here. Just note down, I will discuss. And I'm asking you, after noting down, please let me know this question, answer for this question. Coplanar concurrent force system, coplanar concurrent force system we have. What is the meaning of this? All the forces are meeting at one particular point on a particular body. They are meeting at one particular point. Let me just show the point also so that you will not confuse. This point A. Sir, what is the forces? F1, F2, F3, F4, F5. Now it is more than two force, more than one force. So we can call what? Force system. It's a coplanar. All are acting in the same plane. Do not worry about the planes. They are acting in the same plane. Now tell me whether what will be the static equilibrium condition for this case. What will be the static equilibrium condition for above case? Let me give the option. Option A. Do not worry, I'm giving the option. Summation of forces along the horizontal and summation of the forces along the vertical direction must be 0. Option B, summation of the forces must be 0 in x and y. Suppose that they are there in the what? XY plane. XY plane. They are not in the YZ plane, they are in the XY plane. And summation of moment about Z must be 0. Option C, summation of forces will not be equal to 0. Summation of Fy must be 0. Summation of moment about Z must be 0. And option D will be none of the above. Sorry. Tell me which option is correct. I'm just giving the option for question number 1. Suppose that. I want the answer from all of you because you know the meaning of what do you mean by the movement? What do you mean by the summation of M means movement. Summation of movement by what? All the forces, right? And you know the meaning of forces also. So you can clearly tell me which option will be correct for this particular case. Tell me, guys. Very, very fundamental thing. Yes. A, B. Which option is correct? Let me just play with that option. Suppose that moment will not be 0. Now tell me which option is correct? A, B, C. Of course, D will not be possible or will not be feasible. What will be the, suppose that necessary? Or let me just give one more term. What will be the sufficient? What will be the sufficient, static equilibrium condition for our case? That will be, perfect question for this particular case. What will be the sufficient condition, sufficient static equilibrium condition for this coplanar concurrent force system? My different option is correct. Why you are thinking so much? Moment will automatically balance out. My dear friend, when you just take the moment about point A, force is passing through the same point. You know that summation of moment. Suppose you are calculating for force F1. What about the distance? Force into distance 1, 0. Force into distance 2, again 0. In fact, you take for F3, F4, F5, all are passing through the same point. They can't generate the moment about the same point. They have to have some distance. See, when you have applied the force like this, they will generate the moment, but the moment you are applying the force like this will not possible to generate the moment. So what will be the necessary condition? This will be the necessary condition, right? Because summation of all the forces in the horizontal direction must be 0. Because suppose it is not going to 0, then what will happen? The body may be translating in the x direction like this. And that may be possible that summation of horizontal forces must be mass into acceleration in the x direction. And that will be beautifully covered in the what? Dynamics chapter. Do not worry about that. Right? But movement, this will be 0, this will be 0, and the body will be under rest condition or under uniform motion conditions. Yes or no, guys? Most of the time when we talk about the static equilibrium condition, we talk about the body under rest condition only, right? Yes or no? Because maintaining the uniform motion is not possible until unless we have the force, right? Done? Tell me, guys. Is it done? Perfect. So whatever mentioned in the slide right now, that may be the sufficient condition for what? That may be sufficient condition for what? Coplanar non-concurrent force system. Because, my dear friend, what will happen? Suppose that a body is there, body AB, on that so many forces are acting. F1, F2, and F3. For maintaining the body to be under the rest condition or under the static equilibrium condition, summation of forces along the y direction must be 0, and summation of moment about any point on the body, either you take the point A, you take the point B, movement has to be 0. Movement has to be 0 so that they will not rotate, right? And this is what? And what about this example? Coplanar and non-concurrent force system. You can also call coplanar parallel force system. Yes or no, guys? Please check it out. Do check it out. Understanding or not? Tell me, guys. All of you are understanding or not what I'm discussing right now? If it is done, please let me know. We can discuss about some problem. If it is done, please let me know. We can discuss the last problem, then we can close the session. And remaining force system, I will give that all the particular static equilibrium conditions in tabular format for all the force system. Do not worry. Right now, let me just discuss one last problem for today's session so that you will be having some confidence for solving the problems. Now, you just take about the Uttarakhand, Public Service Commission. I just told you we are going to solve all the PSU and Public Service Commission examinations, right? From all these states. A rigid body is subjected to non-coplanar concurrent force system. Little bit tough, but I believe that you can answer. If the body is to be in the remain state of equilibrium condition, then what should be the static equilibrium conditions will be required to follow? Option A, B, C, D. Try to answer. Take your time. Take your time. I'm just talking about the non-coplanar and concurrent. Non-coplanar and concurrent. It is possible. It is possible that all the forces may not be acting in the same plane, but they may be meeting at particular point, single point. Which option will be the correct one? Concurrent, non-coplanar. When they are talking about the concurrent, do we need to balance out the moment? Do we need to balance out the moment? Then B and C will be gone, D will be gone. And you know that when the forces are acting in the different planes, my dear friend, when the forces are acting in the different planes, the summation of all the forces in the horizontal direction must be 0, in the y direction must be 0, apart from that, along the z direction must be 0, because it's a 3D system. I already mentioned non-coplanar means 3D force system. Suppose that D option would have been mentioned, summation of forces along the x direction and summation of forces along the y direction. Then some of you might be confused with the A and D option. Remember, only A option is correct. Understanding or not? All of you, please let me know. Understanding? I believe that I have added some valuable things to your particular what the knowledge you might have before this particular segment. And this is only the what we can say that very brief introduction about the course called engineering mechanics. Once we have the basic fundamental understanding, we can play with the subject. I believe that. Yes or no, guys? Yes. Right. So anybody having any doubt whether I'm moving fast or slow, then just give me the feedback so that from the tomorrow's class we can just improve on that. Cutoff is for DT 121 and 123 around that. I think this is for I will check it out. This is for OBC, and for general it is around 131 out of 160. I will check it out. I will just check it out and I will make the correction for that, right? For AWS, maybe, in between in this range only, 122 or 124, something like that. So anybody having any doubts, please let me know. Yes, slides I will share in the group itself. Whatever the slides are there, I will share. Is it done, all of you? All of you have noted down? Perfect. So thank you all, right? Yeah, thank you. Yeah, thanks. We'll discuss more and more things we will explore. Do not worry about anything.